All right. Good evening, students. I welcome you for the session and lecture 4 on transition elements. I already discussed some very important lectures on transition elements, their physical properties, atomic properties we have discussed, and we have discussed, students, how the radius, atomic radius vary in 3D series. And when we move from 3D to 4D, there is an increase in size, which is expected because of the addition of new shells. But as soon as we go from 4D to 5F, 4D to 5D series, we find that there is a contraction in the size. The size of 5D series element becomes almost equal to the size of the 4D series. What was the reason for that, students? Very important reason has been given. What do we call that? What do we call this?
Lanthanoid contraction.
Yes, that's a very
Lanthanoid
important.
contraction.
That's a very important result, very important consequence, and that this is a very important point where we have said that you are saying that you go from 3D to 4D, the size increased, students, atomic size is increased, and soon as you go to 4D to 5D, you find the 4D is almost of same size
Is
as
a 5D.
5D. So this is a result of the lengthened contraction. Very, very important question for the paper, students. Why there is a lengthened contraction? What is the reason of the lengthened contraction, student? Due to
A
poor.
poor screening effect of 4f orbitals.
Okay, poor shielding or screening of 4f orbitals. 4f, as soon as they are completely filled, the shielding effect, you already know, S is more than P, P is more than D. F orbitals are bigger and diffused, and the 5Fs will be still more diffused, as we will see in the case of actinides, students. So, what is the important point here? The contraction in size took place, and this is an important thing that what we find, students, the question have been asked many times. For example, zirconium student, and hafnium, zirconium and hafnium have similar question. Now we are discussing large number of question answer in our lectures that you are aware of. Zirconium and hafnium have similar physical and chemical properties. Why? And chemical properties. This question was asked in the paper, students. So zirconium and hafnium, they are having similar physical and chemical properties. What answer you are giving for this, student? What answer you are giving for this? Here, see that zirconium, this is our zirconium and this is our hafnium. Zirconium belongs to which series, student? Which we have already indicated that this is our 3D series, this is our 4D series, and this is our 5D series. Zirconium belongs to 4D series. 4D series, zirconium belongs to 4D series, student. This is the 4D series, and this is your 5D series. 5D series.
5D.
So this is hafnium and this is zirconium. You can see that they have almost the same size.
Yes, sir.
Therefore, what is the consequence of that?
A lanthanoid contraction. Poor screening
That
effect
is
of
all right.
4f
What
orbitals.
question was asked, student? That zirconium and hafnium, they have similar physical and chemical properties. They will show similar physical and
Chemical properties.
important question for the paper. What answer you have given?
So due to lanthanoid contraction.
That is not the answer of this question. Here, lanthanide contraction has already taken place due to there are the size. We are saying the size of the zirconium and hafnium are almost equal, student, because of the lanthanide contraction. The size are important.
Okay.
So what is happening here? When the size of the atoms will be almost equal, students, their radii are almost equal. They have similar radii. Similar radii. Due to, if they ask you why they have similar radii, if they ask you, then that is due to lengthened contraction. What I am trying to tell you, student, that the answer has to be according to the question. What my point?
Okay.
When the sizes are equal, students, then we are expecting them to be of almost equal. I mean, what properties, physical and chemical, are going to be quite similar. Zirconium is 160 picometer, and hafnium is almost equal, 159 picometer radius.
Okay.
So, depending on the question, we have to answer. This is an important question asked so many times. That's why we have given it a thought, students. Okay. So here we have got something very interesting, and this is the most important part of it. There is a lengthened contraction, student. So you have seen that we have shown you the various physical properties, how they are varying. Now the further important point is, if I see the ionization enthalpy, student, ionization enthalpies, we have discussed their enthalpies, melting points and boiling points, hardness. We have already discussed these points. Densities we have discussed how the density is increasing, student. So now we're talking of ionization enthalpies of this. When I talk of ionization enthalpy, student, in this case what you are finding, that the values, first you are having ionization enthalpy 1, delta ionization enthalpy 1, which will mean removal of one electron. Then we are talking of delta ionization enthalpy 2, that means removal of the second electron. And
Electron.
delta 3, ionization first. This is you are calling as the first ionization enthalpy, students, second ionization enthalpy, and third ionization enthalpy. So the story is like this. You have shown the configuration to be ns2, n ns2, and what do you have? Ns2, and here I'm rubbing it. What you said? N minus 1, d 1 to 10,
NS2.
and ns
Yes, sir.
1 to 2.
NS1 to 2.
Okay, so when you will remove the electron, student, the first electron, if you will, you are talking of the first ionization enthalpy, the first electron will go from where? First electron will be removed from ns, which is the outer one.
S.
ns
S.
ns is the
NS.
outermost. So after you will remove one electron, what will happen? If this has only one or two electrons, then again there will be some reorientation of the orbital. What is happening? The energy level difference between n minus 1 d and ns is not much. They are quite close to each other. They
Okay.
are quite close to each other,
Okay.
students. So there is a reorganization of electrons taking place here, and also the energies which are involved. So let us see the value, student. Here what is happening to the value 631, 656, and you see almost same 7. Then it is 7 1 when increasing, almost equal. There is not a very, I mean, there is a some trend as you go from series. You can see there's an increase in general. We are expecting an increase with decrease in size. Ionization enthalpy depends on what factor, students. Ionization enthalpy is inversely proportional to, earlier we have said, atomic size. This is one way of saying that. But there are other factors also operating here. There are other factors also operating here, students. Uh, there could be other factors where you could get extra stability due to electronic configuration. This is one reason. Second, the electronic configuration. Certain places you have stable electronic configuration. So when
Okay.
you have stable electronic configuration, student, it will be more difficult to remove the electrons. If you get extra stability, where you are getting extra stability in case of half filled and completely filled orbitals
Completely
in
filled.
certain cases, then naturally it will be more difficult to remove those electrons. So in general, with a decrease in size, we are expecting an increase in ionization energy, student. Generally increasing trend we can see because with increase in effective nuclear charge, what is happening? The electrons are attracted more strongly by the nucleus. So the screening effect also plays a role in the ionization enthalpy. And in general, you will see that if I go from first to second, what is happening? 1 2 3 4 1 3 0 9, and somewhere what is happening, student? The value becoming 1500 09 1561 1644 1752 1958. Here you see the second ionization enthalpy in the case of the copper 1958 is quite high value, and in the case of this becomes chromium also. Here second ionization enthalpy, if I see, student, what you are finding? Yeah, chromium is how much? High.
Chromium is 1592.
High. And
High.
in the case of copper,
Copper is also high, 1958.
1958. What is the electronic configuration? It is related with the electronic configuration, student. What is the electronic configuration of chromium? Chromium, you have
Chromium is 4s1 3d5.
4s1 3d5. That means after the 1s electron is removed, it has d5, which is a half filled, which is a stable configuration. So you can see that the removal of first electron is not requiring that much energy, but second, there is a big increase in energy in the case of the
Okay.
chromium. So chromium 2 plus will be more difficult to form. It has a higher ionization enthalpy due to extra stability of half filled. So half-filled means they are more stable. Electrons are more stable here in the 3d5 because of the exchange energy. And in the case of copper, what is the configuration, student? Copper.
Copper is 4s1 3d10.
So naturally, what will happen after first electron is removed? It
It
is
is fully
3d10.
filled.
So the d orbital is completely filled. Therefore, you see very high value for the case of the copper.
Yes, sir.
So here it has 3d10. Copper plus 2, student. The ionization enthalpy is high because of the 3d10 configuration is a stable one, so it is difficult to remove this electron from this. Further, you can see one more interesting thing here. If I go from +2 to +3, student, again, if I go from to the third ionization enthalpy, I am talking of the third ionization enthalpy. Here also some interesting trend may come. You can see where the values are very, very high. What we find, student, again, what is this value? Oh, this value is very high. Which one is this? Zinc.
This is zinc. Yes, sir.
For zinc plus 3 is very difficult, and it doesn't exist, you know that. From plus 2
Yes,
zinc.
sir.
Zinc in plus 2, you know what is the configuration of zinc? 3d10.
3d10.
So
It
if
is
you want
fully
to remove
filled.
electron from 3d10, it will be very, very difficult, students. So that value is quite high. Further, you can see what is happening, students, in the case of the manganese. What is manganese?
Manganese Mn. Yeah.
Manganese from plus 2 to plus 3. Manganese, what is the configuration of the manganese in 2? Manganese is 3d5 plus
Manganese
2.
is yes, sir. 4s2 3d5. 2 removed 3d5. Yes, sir.
Manganese 2 plus is what? 3d5.
Yes, sir.
So therefore, it will not, it will be higher energy will be required to go from 3 plus. So manganese 2 to manganese 3 plus means you will need very high energy. Or it may like to go from manganese 3 to manganese 2 plus because it becomes extra stable. It becomes extra stable. So to some extent, we are saying D5, which is Mn2 plus D10, Zn2 plus ions, you see. Therefore, it will be difficult to remove electrons from D5 and D10 configuration. D5 is which one? Mn2 plus. and D10 is
M2 plus.
Zn2 plus. So we are expecting that it will be difficult. So although we don't see a very regular type of trends, as it is dependent on many other factors, but we can see how we explain these facts student in exams or anywhere if questions are given. There sometimes there is more than one factor which is involved, and the oxidation state greater than 2 may not be possible for certain elements, and they will not show. For example, copper, nickel and zinc. Copper, nickel, and zinc, they do not form very higher oxidation state than +2 because the ionization enthalpies are greater. So there is some amount of I mean guidance given by this, but there is not. It's a complex thing. It is a complex thing. We admit that. We admit that. All right. So we
Okay.
have got some idea about the ionization enthalpy. The only thing which we want to tell you, student, where there is a half filled or completely filled, extra stability is there, and it will be difficult to remove electron from those extra stable configurations. That is our conclusion. Okay.
Yes, sir.
All right. Now we are coming to the more important property, student. More important property. Now this is something very important. The oxidation states we have always been discussing. The first question itself is that transition elements transition elements exhibit variable oxidation states. Why? ये question has been asked. Exhibit variable oxidation states. Why? First question before us on the screen. Why do D block elements have variable oxidation? This question has been asked many times in the paper. Now, what is our answer, students? What is our answer? What do you mean by variable oxidation state? If you go to see what happened, if you have S block elements, ठीक है? The first
Yes,
group
sir.
element, what was the oxidation state? +1. Second group element,
+2.
+2. But in transition elements, you are showing large variety of oxidation states. As you can see in manganese, I am showing +2 to +7, +2, +3, +4. So what is the reason for this, student? What is the reason for this? That is our first question in the screen. What answer you will give?
Sir, because of incomplete filling of d orbitals.
In the S block, you only had NS1, NS2. Which
Yes,
orbitals were
sir.
involved? NS orbital.
NS.
In the bonding, NS orbitals were involved, which are mainly forming ionic type of bonds. They are loser, electron losers, metallic. But in this case, students, you have n minus 1d and ns orbitals are involved. Both take part in the bonding. N1 minus 1d. These are partially filled and ns orbitals. So due to the participation of n minus 1d and ns, both type of orbitals, they show a variety of oxidation states. Usually I have told you this, they are responsible for formation of ionic bonds, students, and they are responsible for formation of covalent bonds, etc. Covalent
Yes, sir.
bonds, I mean there is nothing, etc. So what we find, students, that in bonding you have n minus 1d partially filled orbitals. You have partially filled n minus 1 d orbitals, and you have ns. So because both can be involved in the bonding, so the result of this is that they will show variable oxidation states. But except which element shows only one oxidation state? Question number 2. Every type of question has been asked. Which element, students, will show only one oxidation state?
Zinc.
Zinc shows only +2. And if you go, this is which group? Group 12,
Yes, sir.
zinc, cadmium, and mercury.
Mercury.
What was the atomic number of zinc?
Atomic number of zinc is 30.
Then what is the atomic number of cadmium? I will add 1848. What is the atomic number of
1848.
mercury? I will add 32.
32.
What will be that?
Uh,
80.
80.
So well, we have tried to revise so many things for you. And how do we calculate these also? We are aware of it. They are not showing variable oxidation state, student, here. Further question. Question answers. Further question was asked in the paper. Why scandium shows only +3 oxidation state? Every question has been asked in the exam, so make it sure. Why the scandium shows only +3 oxidation state, students?
Scandium.
I have shown here scandium is showing +3. Scandium is showing +3 oxidation state. What is the electronic configuration of scandium, student?
Uh,
Argon. What is that?
Scandium is 21. So
Alright.
4s2 3d1.
So if it becomes scandium 3 plus, then what it becomes? Argon.
3 plus it will be 1 2 here 1. Yes, sir.
Now it becomes
Argon.
stable,
Okay.
stable noble gas configuration. So it adopts a stable electronic configuration. It becomes highly stable electronic configuration. Therefore, scandium shows +3 oxidation state. Question answered?
Okay, sir.
You have to see what answer we have to write in the exam. You can't write everything. Question. Next question on the screen, student. Which element has highest oxidation state? Which
Uh,
element has highest oxidation state in 3D series?
in 3D it will be manganese.
Answer is manganese. What is the electronic configuration of manganese, student? Mn.
Manganese is 4s2 3d5.
So it shows up to +7 oxidation states. +7 oxidation state. You can see that for manganese there is a +2 to +7, student. This is a table which is a table given in the book, students, where we have shown you the common oxidation states exhibited by the transition 3D series. By the transition 3D series, the bold letters are the more stable oxidation state, the bold ones. Manganese +2 is highly stable. Manganese +2 is highly stable. Why? Because after that it is left with 3d5.
3d5
So this is extra stable configuration. Extra stable
configuration.
configuration.
Mhm.
So iron you have seen +2 and +3. Again, we try to go and see the electronic configuration wherever it is possible, students. And these are the stable configurations. What is copper 2 plus?
Copper 2 plus will be 3D copper 2 plus 3D9.
Copper
3D9.
2 plus is 3d9.
Yes, because one will go from S and then one from D. It has
Okay,
4s1
we
3D.
will give reason of that also because we will be talking about all these things. Zinc plus two already you have seen what is zinc plus two. 3d10.
Yes, sir.
So zinc is always existing in zinc sulfate or zinc chloride, all those plus 2 oxidation states. Plus 2 oxidation states we have seen. And here nickel plus 2, plus 3, plus 4, plus 2. And iron you can see mainly plus 2, plus 3, but few other oxidation state also exist, which we have shown for different elements, In general, one more thing is clear, students. What is that clear? You see that the lowest oxidation state is lowest oxidation state which is shown is the number of electrons in s orbital. Number of electrons in the
S orbital.
s orbitals. If you mostly you have two, then plus 2 is shown. But in some cases plus 1 is there. Now why copper plus 1 is there? That question comes. Because you have said the configuration of copper is what? What is the configuration?
4s1
3d9, 4s2
2.
or 3d10, 4s1. ठीक है?
4s1, yes, sir.
Okay, 3d10, 4s1. So it has one electron. If it is removed, it is quite stable. So copper shows cuprous and cupric. Copper plus 1 is known and copper
So,
plus 2 is known.
sir, for
Cuprous.
this, copper plus 1 should be more stable, now.
That we will answer the question. We will answer all these questions in this chapter. There is a lot of things to come. Just keep on noting. Because once you put a iron in solution, so many other things will happen. We will answer all those questions. Okay? But right
Okay.
now, what we are showing that this oxidation state plus 1 is not shown by anyone.
Yes, sir.
But copper shows plus 1. That becomes a question in the paper. That which element shows plus 1 oxidation state? What is your answer, students?
Copper.
Copper. These are the questions which are asked students. Which has the largest number of oxidation state? That question has been asked. Which is I'm showing plus 1, which shows only 1. Why scandium shows only plus? All these are questions for the papers. Now, when I say which element has the highest oxidation, D block element, student. D block element is not 3D. A D block element will mean 3D, 4D, and 5D series. 3D, 4D, and 5D series, students. And you will see that osmium shows plus 8. Osmium shows plus 8, and rhodium also. Rhodium also shows plus 8. RH. So maximum oxidation state question was asked. It is not the manganese, it is osmium. Plus 8 oxidation state is exhibited by osmium and rhodium. All these points to be noted down, students, noted
Yes,
down.
sir. Yes, sir.
Because there are a lot of interesting things, which a table means a lot of information. It depends how much how we think on all these things. One question will be there on these oxidation states, students. Now the question will be that which when higher oxidation states will be there, they will be formed with which elements? Another question for the paper. Can I rub this if you have noted down?
Yes, sir.
Okay. Every point is important. Be noted down by student. You see that when I discuss, whatever questions are possible, I go for all that. They have been asked somewhere. I mean, it's not that. Okay. In every group, oxidation state is a big, vital, important thing because the chemical property, the compound formation, all this is the result of the when we discuss oxidation state itself is a concept which was given to explain the type of compounds which are formed by the elements. Answers come when we start thinking. It is not mugging nothing. How do I mug all this? Not possible. Every question has to be answered intelligently after giving a thought. What is the reason? Reason is important. In organic chemistry, all you have seen what we are doing, providing answers, explaining answers, students, to you. What was the question now? You have been shown the stable oxygen. Minimum is NS, number of electrons in the NS, that we know. And maximum is where you will have more unpaired electron, students, naturally, because the d orbitals are taking part in the D orbitals are taking part in the bonding students, and maximum oxidation states are shown. The more the unpaired electrons, more oxidation states are expected students. And the question now is with which elements you will get higher oxidation state, higher oxidation states, which elements? Always you will see which elements you are getting higher oxidation states. Student, what is your answer, students? What is your answer?
Uh, Manganese.
Which element manganese will combine to show higher oxidation state? Manganese, we already told you that it is showing +2 to +7. And +7 is also very stable oxidation state of manganese. +2 is also that we have shown. But which elements? Highly electronegative element, that you already know that. Which are the highly
Okay.
electronegative elements, students?
Fluorine, oxygen, and nitrogen.
So mainly with fluorine and oxygen, these oxidation states will be there. Even nitrogen is not that electronegative. These values are given to you in a lecture in organic chemistry, journal organic chemistry. I have taught to some students. You can watch that video.
Okay.
So mostly we are expecting with fluorine and oxygen because they are strongly electronegative elements, strong oxidizing agent. And one more thing, I tell you that if palladium, you will see the configuration of palladium, it is 4D10 and 5s0. So palladium 0, S0. Certain important exceptions which exist should be known to us, should be known to us. So minimum +2, but copper +1. Rhodium, osmium showing +8 oxidation state. Also oxygen and fluorine are likely to form highest oxidation state. And another question was that Mn2O7 exists, but MnF7 doesn't exist. Interesting that this is +7, this is also +7. +7, +7. Hey, this is stronger oxidizing agent than oxygen.
Yes, sir.
One thing, something is that's Mn2O7. No, this is the okay, Mn2O7. Okay, okay. Now what is the story? There are two manganese. Okay, okay. What do you think? What is the happening? Fluorine is more electronegative than oxygen,
Oxygen.
but then this is not existing and this is existing. This question was also given. How the questions are asked is important, student. There is some amount
Uh,
of point required.
but sir, fluorine has the smallest size. So,
Then what? Fluorine has there are, you see, this one manganese with seven fluorine. One manganese with seven fluorine is not going to be stable. Why? But oxygen can show +7. Oxygen can form multiple bonds, student. What it forms? Multiple
multiple
bond.
bonds.
You know, p pi bond in oxygen. P pi or p pi d pi bond. This is a possibility. Oxygen double bond. Oxygen double bond. Fluorine always single bond.
Okay.
Fluorine is 7, 7 plus 1, 8. Fluorine cannot be double bond. Can it be? Oh,
No, sir.
how many? 2, 4, 6, 7. Single bond. So you will need 7 fluorine. There will be a huge amount of crowding. Very difficult.
Okay.
But in this case, is Mn2O7. And the oxygen can form multiple bond. Therefore, there will be lesser number of oxygen with manganese, student. Mn2O7. Mn2O7. If you will see the structure of this, we will see the structure of this later on. Mn2O7. How it will look like. Then there will be some oxygens. What is the story now? Then there are how many oxygen? Four, and hey, there are seven atoms going to surround it. This will be very difficult because a double bonds formed by the oxygen. The number of oxygen becomes less.
Yes, sir.
and therefore the crowding will be less, and then this can stabilize, but it will be difficult. See the question answers, we have to think. Without thinking, can I answer a question, student? So many questions I have told you. And they have been asked in competition also. This table means a lot to us students. It's not that just see, more than 20 questions have been put right now.
Okay.
Questions are framed, students. Questions are framed. They are prepared. Questions can be prepared. So how they are prepared, student? That is the question. It's not that what is written in the book. Anything can be made. Basic thing same. We don't understand the basic concept, one answer we are going to give. Nothing. Okay. Is there anything left here, students? Is anything left? There is one question you already asked, that copper plus 1 is less stable than copper 2, but in solution it is copper 2, because that the value of the electrode potential, student. I am talking of electrode potential values. The answer will lie in the value of the electrode potential. We'll see that. You have seen a table of electrochemical series, electrode potential values. When you put something in aqua solution, what happens? It is not only the ionization enthalpy. Students, there are other factors involved in the solution. The hydration enthalpies, atomization or sublimation enthalpies, all these are involved. All these are involved. And what will be the nature of the compound? Another question comes now. Oxidation states you have told. ठीक है?
Yes, sir.
And if I saying that, what is the nature of compounds? Is it related with the oxidation state, students? Whatever I talk, it will be applicable for all the groups. It's not that, because it's a basic, I'm talking of fundamental concepts. What is the nature of the compound? What type of compounds you know? Ionic and covalent?
Ionic and covalent.
Okay. Ionic and covalent compounds. So what will happen, students? You are saying that in transition element you are having plus 2, plus 3 oxidation state. They are lower oxidation states. Lower oxidation states, yes or no?
Yes, sir.
Okay. Then you are saying there are plus 5, plus 6, and plus 7. They are higher oxidation states.
Yes, sir.
So which compounds are expected to be ionic, which are expected to be covalent, students?
Sir, lower oxidation state compounds will be ionic and the higher ones will be covalent.
Covalent. When I write copper sulfate, copper chloride, student, you are saying this is 2 plus and 2
2
minus.
plus, 2 minus.
That is what you say.
Yes, sir.
But when I write, student, if I write MnO4 minus KMnO4, KMnO4, which is used as strong oxidizing agent, what happens? MnO4 minus. This is a covalent. This is covalent. Covalent. Similarly, Mn2O7, students, Mn2O7. Similarly, when I say K2CrO4, student, K2CrO4, chromate ion, chromate ion. When I write chromium, chromium. What is the oxidation state of chromium here?
Uh, K2CrO4. Bloody plus 6.
Plus 6. And we will see the structure of these ions also, because we have in our course potassium permanganate and potassium dichromate, student, potassium permanganate and potassium dichromate. So this is some of this is the information which we have given to you about what, students. I have been talking about the oxidation states of these elements. So these ones which are written in the dark are more stable oxidation states. So we have been able to answer large number of questions here, not on many questions.
Yes, sir.
Now the story comes. The question was raised by you. The question was raised by you students that what happens that copper plus one. I mean, it should be more stable, but copper 2 plus exists, is more stable. Compounds of copper 2 plus you are seeing in all the cases. So, and I said that there is something called standard electrode potential. Standard electrode potential. Now I'm talking of standard electrode potential. You have seen the values of standard in the electrochemistry chapter. What we have shown, Mn plus M.
Yes, sir.
These are called reduction potentials. Reduction potentials. If I take Mn plus Ne, this you call as reduction potential, student. This was aqueous. ठीक है? This is a reduction potential. You have been shown under standard condition. For example, if I take 1 atm pressure and 298 Kelvin temperature, these values were calculated and a table was produced. If this is a reduction potential, if I reverse it, what it shows, this is called oxidation potential.
Oxidation potential.
Okay. It is only our just to answer certain questions we can see. More positive, this means it will the element will lose an electron more readily. But what are the factors on which the how the standard electrode potential values are calculated, students? How these values are calculated? Standard electrode potential values, how they are calculated, or what are the factors on which it depends? You are saying that first of all, you have a metal solid. What you are forming? M plus G plus electron. This is what delta sublimation.
So, okay, delta sublimation. अच्छा, solid to gas. Yes,
Is
sir.
it positive or negative? Positive. Energy will be required to remove an electron or to, I mean, no, I should not say like this. Wait, let me. This is sublimation. It is not yet plus. We have done. We are just revising. Just wait. Okay. This is not sublimation. Make it. I am saying first thing will be sublimation. Sublimation means what? Where am I? Pen. Okay. Sublimation means solid to gas. So solid is converted into gas. These particles are in solid state. Solid state. If you will remove them, if you atomize them or sublime them, what will happen? You are removing from the solid. You are going to the gas state. ठीक है? Delta
Yes, sir.
sublimation is positive. Number one. Second step. This is ionized. Ionized. If one first ionization enthalpy, if two, then I will do another ionization. Okay.
Okay.
Delta, what is this called? Ionization enthalpy. Is it positive or negative? Positive.
Positive.
Let it be plus x, let it be plus y. ठीक है?
Okay.
Some value. Third, what will happen? This goes in the solution. What is that? Aqueous. Aqueous means what? Water. Or any solvent, mostly water we are using, then we are saying M plus aqueous. Hydration, delta hydration. What is this, positive or negative? Negative?
Negative.
Okay. Let it be minus Z. What is that total delta H, students? Plus X.
It will be x plus y minus z.
Now the sign could be positive or negative. It will
Yes,
depend
sir.
on these three factors. Hey, if this is hydrogen enthalpy, this is if these two values are very high and this is less, what will happen? What will happen? Then this value is positive.
Positive.
This value is positive. So this is how these values are calculated. This is how these values are calculated. Standard electrode potential values are calculated on this basis.
Okay.
It is not simply ionization enthalpy. There are three factors involved in it. So what is the story then? The first important point here is students, you are saying unique behavior of copper. Unique behavior of copper, you are saying. You have asked that question. What is interesting? Let me see. Where is copper? What do you see? Copper E naught value means what? Copper 2 plus 2 copper is how much? Plus 0.34 volt. Given?
Yes, sir.
Okay. Copper is 0.34 volt, student. And if I compare it with where is a where is a copper zinc? What is a zinc? Minus 0.76 volt. ठीक है?
Okay.
So zinc is minus 0.76, copper. All the elements are minus, but copper is positive. First important point. First important point. What you have seen? That copper is positive and
Yes.
zinc negative.
Negative.
So can you explain? Can you explain why copper is positive and zinc is negative? Why? Why copper is positive and zinc is negative? Why copper 2 plus 2 copper is positive? That is the first question, student. What is the reason? Copper 2 plus. What is happening? What is happening here? There are, what is the ionization energies? Let us see for copper. This is my first ionization, and this is second. Delta H1. This is our sublimation. First, second. Where is copper? This much. This value 339. These values are quite high. See, high, high. This is not that high also. The sublimation energy, enthalpy, and these values are high for copper. What are high? This my plus X and plus Y are high. What are those?
Okay.
Delta sublimation H
Sublimation
plus
and
delta
ionization. Ionization.
ionization. Delta ionization for copper high, X plus Y high,
Why? Okay.
positive high. And what do you find? Hydration enthalpy. Where is hydrogen? Minus 2, 1. What is copper? Minus 2, 1, 2, 1. So hydration enthalpy is not that high to compensate it. It is okay, but it is not that high. You can see. So therefore, there is a hydration enthalpy. Plus 2 is more than plus 1 for copper. That is the reason plus 2 is more stable than plus 1 in solution.
Okay.
But the here delta hydration is not able to, not not too high as compared to the plus energies. Plus energies. If the plus energies are higher than the negative energies, then that is the reason that for copper the electrode potential value is positive. First question.
Okay.
Therefore, we see the first question is the why the value of the copper is plus electrode potential, whereas rest of the elements are having minus value. So the answer lies in higher sublimation and higher ionization enthalpies, not compensated enough by the hydration enthalpy of copper 2 plus.
So, sir, for other elements, it will be like delta H sublimation and delta Hi are compensated by the high hydration enthalpy.
Of course, when negative value is more, naturally it will become negative. That's what we are saying. That is what we are saying.
Okay.
So the high energy is required to go from high energy is required to go from copper S to copper 2 plus. ठीक है?
Okay,
High
sir.
energy is required. ठीक है? But not balanced by the high energy requirement. This it requires high energy. It is not balanced by the hydration enthalpy. Not balanced by hydration enthalpy. Therefore, the value is positive. If value is positive, what will be the consequence of this? Value is positive. E naught is positive. You are saying, student, you are saying that E naught means copper 2 plus 2 copper is positive. plus 0.34 volt. That means this value is positive. What it means? That means this state is less stable.
Yes, sir.
Copper can gain electrons to form copper. Copper will gain electrons to form copper. Or this is more stable as compared to 2 plus. Therefore, copper is not going to give electrons. If copper
So,
cannot give electron, it cannot act as a reducing agent. Or in other words, if I have HCl and if I put copper, what will happen? What will happen? If I
it
have,
will not liberate hydrogen.
so it will not liberate hydrogen. Not liberate hydrogen. Not it will not liberate hydrogen. So copper is not going to liberate hydrogen. It will not liberate hydrogen. Copper. Copper does not produce hydrogen in this weak acids. If you have strong oxidizing agents like nitric or concentrated sulfuric acid, it may be reduced because they are strong matlab, acids. So they are strong oxidizing acids only then, but not with others. Whereas zinc will reduce, zinc will produce hydrogen gas if you add in HCl. So some of the first two ionization enthalpies and hydration enthalpy is involved, and you have find that for zinc the value is more negative. This is more negative. So what is happening here? What are the energies involved? You can see sublimation, aqueous. This is related with the configuration. What is the configuration of Zn? 3d10 4s2.
Yes, sir.
So losing of two electrons will make zinc highly stable. So the reason you see is that what happens, you can see what is happening in the case of zinc. This is the first ionization enthalpy, second ionization enthalpy, first ionization, it is atomization energy. Atomization energy of zinc is very small. See 130. Small, value less,
Okay. Yes, sir.
less. Because zinc 3 day 10 completely filled,
Fair.
the bonding is weak. This is less, and this second ionization enthalpy also is not that high, and see the hydration enthalpy is quite compensating, therefore it becomes quite negative. Similarly, let me see the manganese also. You see manganese has very high value of the very high negative value here, minus 1.18. So they are more expected, more negative than expected. There is something related with their extra stability of the configuration, students. Extra stability which is related with the configurations. And in general, I can say that in general, when I will be talking of these oxidation state, student, or these values. So what is happening? The more negative the value, more negative the value, that means more stable is that ion,
Iron.
more
Okay.
stable is that oxidation state. More positive the value, less stable is that oxidation state. Less stable is that oxidation state, students. So these values are very important for us. And when we say that, what happens in the case of copper, you will see that if you have copper plus 1 and copper 2 plus, this copper 2 plus is more stable in aqueous medium, student. Aqueous medium. In aqueous medium, copper 2 becomes more stable. Uh, what is the reason for this? Because the hydration enthalpy of copper 2 plus is more than copper plus 1. Hydration and overall energy changes will be favorable for the formation of copper 2 plus ions when it goes in a solution, student, when it goes in a solution. And
Okay.
that is the reason you will see that copper plus 1 will change into copper 2 plus state. So the values of, if we have the value copper plus 1 and copper 2, for example, if I say this is my copper plus 1 to copper, ठीक है, this value E naught is plus 0.52, plus 0.52. And if I take copper plus 2 to copper plus 1, this value is 0.34. 34. This is not, this is two electrons, two electrons. So what it is, let me just make it management. Okay. What I'm saying, copper 2 to copper is plus 0.34. Now in this case,
Okay.
student, which value is smaller? 0.34 is less than 0.52.
Yes, sir.
Therefore, what is the story here? That plus two state is more stable than plus one state. Plus two state is more stable. So copper is more stable in which state? Copper is which stable in which more state?
In plus 2 state.
Plus two state, because this value of the reduction potential is lower.
Okay.
So copper 2 plus is more stable. In aqueous solution, this is in aqueous solution because electrode potential values are given in aqueous, student. These
Okay.
are aqueous student, aqueous. So copper 2 aqueous is more stable than copper plus 1 aqueous. These values are reflected by their electrode potential values. So lower the
Okay.
electrode potential value, the more stable is that oxidation state. Everything we have to think and apply mind, students. All right.
Yes, sir.
Okay, we'll continue more discussion and more questions on this because it's an important concept, because it requires more thinking. You can also think more about this. This I've tried to explain because more questions can be asked on this concept. We'll continue in our next class then. Okay, good night.
Okay.
Meet you in the
Thank you,
next.
sir. Thank you, sir.
Okay, good night.